When working with discrete probability distributions, we need to review some of the key terminology as well as some new terminology. First, we have what does it mean to be discrete? Simply put, discrete means to be countable or finite. We will also be working with what it means to be a random variable. We're going to be using the generic variable x a lot to be representing a variable where this has a value for each outcome of a procedure that is determined by chance. A discrete random variable. This is just a variable with a finite or countable number of values. Again, this is going to be very important because as we move along in the discrete probability distributions, we need to be able to account for all of the possible values in our scenario. A continuous random variable. This has an infinite number of possible values for the variable. Notice that a discrete random variable and a continuous random variable look very similar. The only difference is that whether we can make one countable or not. A discrete random variable is something like counting the number of kittens in a litter, while a continuous random variable would be something like temperature or time or height that can be broken down into smaller pieces. A probability distribution that we're going to be working with. This is going to be a table that's going to yield the probability for each of the random variable x's in our scenario. To be able to do all of the work with our calculator feature and all the formulas that we're going to use, we first need to be able to determine if a probability distribution is even valid. So you have two things you need to be able to show. First is that all of the probabilities in the table are between 0 and 1 inclusive. That means that the probability of an event occurring can be 0, or it could be 1, or it can be any decimal value in between. The things it cannot be is it cannot be a negative probability, and you cannot have something occur over 100% of the time or over 1. You're going to visually look at this and check off if you see that it is done or not. Does it meet the requirement? The second is that you need to be able to sum, and that's what this weird little kind of bracketed or boxed off looking E looks like. This means the sum of all the probabilities is equal to 1. Now sometimes because of the rounding rules or the way that a probability distribution has been rounded, it will not add up exactly to 1. Because of the way that things are rounded when we're looking at a distribution table, we will also allow for the sum of our probabilities to be slightly off, such as 0.999. This is super close to 1, and again, if we were to calculate the probabilities using the formulas rather than just the chart that was given and rounded for us, it might actually be equal to 1. Same thing if we are slightly over. Again, tenths, hundredths, a thousandth of a value off from 1, we're still going to allow this. So we're going to check both of these before we move on. We're also going to be using the 1var stats calculator feature. Unlike what we did before where we just used the list feature only, we're also going to be using the frequency list. When describing on your paper the calculator feature you are using, you will be writing down the 1var stats. In the list feature, you are going to describe with units what x represents. And in the FREQ list, you are going to have the probabilities or the P of x values.